this is Jessica speaking. I'm gonna talk you through it, all the steps that you need to follow in order to set up an optimizer problem. I'm gonna divide the whole process in 3 videos. This first one will be the video dedicated to the formulation of the problem, so kind of what we started doing yesterday in the tutorial, but kind of continuing and finishing that part. Okay, I'm gonna start from the beginning. There were a couple of things that I forgot to include yesterday, so just take a close look and just check that you're doing everything. So we started here in Optimizer by importing my own data, and the idea is just to go and find the file that we're going to use. I'm just going to go to the specific file. This is the same file that I put in the folder. Projection, we don't need anything because we're not going to work with a spatial reference. We need to validate it first, and once it's validated, then we can open the model. Okay, so remember that Optimizer has different parts, like different windows that are going to help you, like setting up everything. Here we have another window talking about the spatial reference. We just click OK. So we have our project explorer here in the left. We have a data browser in the bottom part, and we have a properties editor and a plan editor that's going to appear later on. Important to know in Optimizer is that we have a workflow, so we need to kind of follow it through in order to make the program work. Right now we're in the model stage, in which we can't do much, to be honest. We can only see like the characteristics and all the pipelines that we have. But the first stage then is going to be the formulation, so this is the first thing that we need to do. We just need to just switch into the formulate stage. The first thing that we need to do here is just to set up the planning criteria. So we need to go to formulation, and in planning criteria we want to have 3 different planning criteria that are related related to the pipe cost, the pressure penalties, and the tank penalties. So I'm gonna create here 2 more. We have one for by default, but I'm gonna change the name to pipe cost, and here I'm gonna call it the variable PC. Then I'm gonna have the pressure penalties, which are gonna be called PP, and then I'm gonna include the tank penalties, that's gonna be called TP. So these are the 3 kind of criteria that we're gonna use to evaluate if a solution is good or bad. Okay, but at the same time we're using only one objective optimization, so we kind of need to merge these 3 in just one variable, and we're gonna do that here in the optimization tab in objectives. If you go here, there is something called fitness. So fitness is precisely the one term that is going to decide if our if each individual is good or not. We just leave currency because we're going to work everything in cost, but then the equation, we need to change it. The equation is going to be the summation of the 3 things that we're using. So pipe cost, pressure penalties, and tank penalties, which means that a good solution will have a really small fitness, because we won't have any we won't be having any penalties, and we will have like a small cost. So that's the first part, like setting up the criteria and the objectives. Once you have that, then you need to start explaining to Optimizer all the different things that you want to change. Okay, so part of the things that we're going to be the only thing that we're going to be changing is pipe diameters. So we need to create, for example, the pipe material tables when we set up the information that gives Optimizer different options of diameter and all of that we're going to be working. So we can find that in formulation and in data. There's something called pipe material tables, and then you go here and we need to create those tables. And for that we're going to go to the spreadsheet that I uploaded in Dropbox, the one that is called pipe material tables, and we're going to simply copy here, copy one, and then come here and paste it. and as you can see, the table is fully pasted here. If in the future you're gonna use this and you need to create a new table, be careful to always create it in the same order. Okay, I'm gonna do the same for the other two. Sometimes we have seen that the option of pasting does not appear, but if that happens, just close the file and open it again. Okay, you can save the project and then close it and open it again, and it should work. Okay, so now that we have this, then we need to kind of now explaining to optimizer which are going to be the potential new residential, new urban, and new rural um, pipelines. So for this, we're going to go and set up different kinds of decisions. First, we're going to start with the pipe decisions. So this is kind of where we're going to say to optimizer, these are the pipes that these are the kind of pipes that you can include, and these are the pipes that are options. Okay, so we need to create three different decisions in this part because we have three categories for pipelines. So we need to create here a new rural pipelines, new residential pipelines, and new urban pipelines. Okay, be sure that you are using the correct planning criteria. And then here is the first thing that I forgot to explain yesterday. You need to also set up the material table. So for new rural, you're going to use the rural table. For new residential, you're going to use the residential table. And for new urban, you're going to use the urban table. That's really important because if not, the costs are not going to be calculated. Okay? And remember that also we need to check some of the boxes. The first one will be allow remove, which means that the program is not going to be forced to use all the pipelines. We're going to have ticked the box to on closing random, which means that in the first few random generations is going to random generation of individuals for the optimization is going to close some pipelines randomly. And at last, we need also to check these three boxes, which are removed closed, which means that once it reaches an answer and it has some of the pipelines are not going to be used, then it's going to just remove them from the model, which is really handy for us. Okay, so now that we have that, we need to now that we have the three decisions, we need to assign the pipelines to those decisions. Okay, so for that we're gonna go to the other spreadsheet that I sent to you, and we have this first big table that is called pipe decisions. We're gonna copy that one. If you check here, what we have is a reference ID, which is new rural, new residential, and new urban, which is the same category that I created in the decisions. And here is the ID of the pipelines that we can change. So to add that, we're gonna go to project, the tab project, and then here there is something called import reference map. And we're gonna import that. This is a decision table, and then simply we say please paste it from clipboard. And it says here that it successfully applied 51 out of 51 mappings, which means that all of the pipelines were successfully updated. They have been included in the decisions. Sometimes it happens that it says like 20 out of 51, and normally that's because the name that you use for this reference ID doesn't match the category that is here. So be careful if you have that error. Okay, so with that we have that for new residentials we can have 31 pipelines, for new rural 13, and for new urban 7. So we kind of have updated that. Okay, the second thing that we need, the second decision that we need to create is the decision for the pressure. So we need to kind of set up the fact that we're gonna have a minimum pressure. Okay, and we're gonna find that in design criteria. So here I'm just going to close this data and these decisions. In formulation we have design criteria. So in design criteria we have tab that is called pressure, and we have two criteria for pressure. minimum pressure of 20 in the demand nodes and minimum pressure of positive if we're talking about the non-demand nodes. So we're going to create those two categories, and I'm going to call them minimum pressure 20 meters and positive pressure. I will recommend you to use exactly the same names because we're going to use another table and we're going to have to keep that in mind. Okay? The planning criteria for this is going to be the pressure penalties, which means each time that you violate these design criteria, it's going to start counting cost in the penalty. And we have several options here, but basically the one that we want to change is the calculation type to worst case. That's because in the case of the pressure, we care about the worst possible hour during that day in which the pressure was the minimum. So that means that that's the only value that it's going to take into account. The minimum value then for the first one will be 20, and for the second one it will be 0 because we want a positive. And then it's really important to include the minimum multiplier or the multiplier because that's what is going to turn a penalty in meters to a cost. So for our problem, we're going to use a $100,000 per meter. And this is kind of a number that we have discovered by trial and error and is problem dependent. But once we run the optimization, I will tell you how to know if the pressure, if the penalties are too big or maybe they're really small. Okay. So now that we have that, we don't need to worry about maximum values because we don't have any criteria for maximum values of pressure. Okay. So here what we created is two conditions that we want to comply with, but again we need to assign some of the nodes to one of these categories because some of the nodes are demand nodes and some of the nodes are non-demand nodes. So if we go back to the reference maps spreadsheet, there is another table here that is called pressure design criteria, and what it has is for each category we have the ID of the pipelines, sorry, the ID of the nodes that need to be compliant with that condition. So as we did before, then we're gonna just copy this table and I'm gonna go to optimizer and I'm gonna import that. So I'll go to project, add, import reference map, and then here what we want to import right now is design criteria, and we just paste it from the clip. It says successfully applied 92 of 92, so it already applied to all the nodes. So remember to keep positive pressure and like the names really well in the same way. So minimum pressure 20 and positive pressure. Okay, so now we have assigned that. The last criteria that we need to establish is the tanks. So we're gonna go to design criteria again, but for the tanks. And what we need here is 3 design criteria because we have 3 tanks. So I'm going to create 3 and I'm going to give it different names. So tank 1, tank 2, tank 3. These are penalties, but that's okay. The planning criteria then is going to be the tank penalties, so we need to change that into 3 of them. Okay. And for the case of the tank, we're going to leave this calculation type, because we want to know if the tank is only violating this during 1 hour is not that bad as if the tank is violating that during half of the day. So we're gonna leave it like that, okay? And then what we need to do is just fill these things over here. At least the most important one for us is the minimum allowable level and the minimum return level. But still we need to set up the maximum allowable level and the maximum return level, even if we don't have any penalties for this. Okay, that's the other part that I forgot to mention yesterday. So minimum allowable level for tank 1 we have 5, which is this kind of the half of the height of the tank. For the second one is 6.1, and for the third one is 5.4. The multipliers for the tanks, we're going to use 1 million. So 1 million, 1 million, and 1 million. And the maximum then allowable level, as I was telling you, is going to be the complete height of the tank, which in this case is 10. In this one is 12.2, and in this one is 10.8. We don't need multipliers because we're not going to calculate any penalties. The minimum return level then is the same as the start level, which is 6.7 for number 1, 9.9 for number 2, and 9.1 for number 3. And then again, the multiplier for those is 1 million for the 3 of them. Remember that these multipliers, then the magnitude of these multipliers is problem dependent. The maximum return level, we're going to leave it as the maximum allowable one. We're not going to use it, but the program needs to know this in order to establish the dimensions of the tank. Okay. So now that we have our 3 decisions, we need to assign this decision to each tank. So we're gonna do this manually. We don't have a table for this, basically because we only have 3 tanks, so we don't have to worry about that very much. So to do that, we're gonna just select one of the tank criteria, and here in the properties editor there is a tab called elements, and we can just drag and release some of the elements there. Here the tanks, you can see them 1, 2, and 3. I think number 1 is this one. If I'm wrong, I will just fix it, but before doing that you need to click here, click selection, which means that anything that I clicked here is going to be selected, and of course nodes. So here, for example, I'm going to select this tank, and all I have to do is drag it all the way to here. 31 compatible element, yes please. And then I just discovered that this is tank number 2, so I have to fix that. So I need to remove it, and then I'm gonna move to tank 2, and I'm just gonna drag it here, because if not, then I'm gonna be crossed. So yeah, this is tank 2. For tank 1, then I'm gonna clear the selection first, and this will be tank 1. So I will drag it here, yes, and then I will have to do tank 3. So again, I clear my selection, I select one of the tanks here, and then I just drag it all the way to the elements editor. And now we have linked the tank with the decision. Okay, be careful not to mix the different tanks that you have available. So kind of up until this point, we have all the formulation of the problem, but we're gonna do one more thing, which is create legends, okay? The legends, which are colors and ranges of values, are gonna be really useful when we're checking the results. So to create legends, I'm just gonna close this formulation and open this map display. There is a tab here called legends, and you see there are legends for a lot of things, but we kind of want to have legends for our design criteria. So I'm gonna create a new legend here. So over here we kind of have an opening to change the name. So the first one is gonna be decision diameter in millimeters. The title is going to be the same. It's going to be a legend type of sections. In which elements? Well, in the pipes, because I want to know the diameters of the new pipes. And the property is going to be the decision diameter that is here. So just as this one, you can create legends for a lot of other things, but we're going to keep it just for the decisions that we're actually making. Okay, so I'm going to do a range of 7 different 1, 2, 3, 4, 5, 6, and 7, and I'm gonna start changing the values here. Okay, what we want to do here is assign a different a different color for each different diameter that we can use. So these ranges that I'm just putting here are according to the tables that we did, the tables that we have for the different pipes. Okay, so you can just copy the same numbers. If you are in the future working with a different problem, then what you want in these tables is to reflect a different color for each diameter. That's going to be really helpful. I haven't changed the colors, but I will change them in a second. And the other thing that I changed was the size. So I assigned a size of 2, which means that every pipe that we change, we're going to see it bigger here. I'm just going to clear, sorry, the selection, just in case. And I'm going to change the colors, okay? You can just choose the colors that you want. It doesn't matter much, as long as they are all different to prevent any confusion. So this is not proper anything to do optimization or nothing like that, but it's something that is going to help us a lot visualizing their results. Okay, and just as this one, we're going to create 2 more. Okay, but before that we need to assign this legend to one layer, what is called layer. So we're going to go back to layers, and this layer is going to be in pipes because I want to show it in pipes. So we come back here, layers, pipes, and then here we can decide on the legend. So I'm going to decide the legend that I just created, and I'm going to say please show layer, and then you can see that here we already have that layer, and we will have it available when we set up the results. Okay, I'm gonna create another table which is going to be the pressure violation. So pressure violation in meters. The title, yeah, it's gonna be pressure violation in meters again. This is going to be again a section. This one we want it in the junctions, and we want the property is gonna be the total pressure violation. Okay, I'm gonna create 5 lines here, 1, 2, 3, 4, and 5, and I'm gonna create a different like scale. So what I'm showing here is that the first category is going to be the pressure violations that are bigger than 20 meters, which means that are really bad. So we're gonna assign a red color. Then if we have something that is between 5 and 20, is still bad, but it's not that bad, so we're gonna assign a orange color. And then I'm also changing the size, which means that those nodes that have more problems are gonna appear bigger. I'm gonna use 1 here, which means that this is between 1 and 5, and this is going to be a size of 1.5. To this one I'm gonna assign a yellow color, and then we have kind of the small category, which is pressure violations between 0 and 1 meter, which is not too bad. So we're going to use it in green because it's good, it's not that bad. And we're going to assign a last category, which is a gray one, which means there is no violation, which is kind of the ones that we would like. We would like to have all our network in gray. So once we create the second legend, then we need to assign it. So we go back to layers, and now we choose junctions, and this junction is going to be please using pressure violation, and then show it. Okay. It doesn't matter much how it shows here the text. What matters are the colors, so don't worry about it if it happens the same as me. We have one more legend to go, so which is going to be the tank violations. So tank level violations, which is also going to be in meters. So tank level violations in meters. We're going to have section. We're going to assign it to tanks in this. We want this violation to be taken care of in the tanks, and the property is going to be here, total violation. I'm going to create the same 5 categories with a slightly different range. So if a tank has more than 5 meters of violation, then it's going to be red. I'm going to change the colors at the end. If it is between 2 and 5, then it's going to be orange. between 1 and 2 is going to be yellow, between 0 and 1 is going to be green, and when we don't have any violation, that's going to be gray. So I set up the values. You can use the same ones, you can change them as long as they are logic, then it's okay. This is a visualization tool, so this will help a lot. So okay, we have the legend ready, and then we're gonna assign it. So we go back to layers, and then we just select tanks here. The legend that I want to see for tanks is the tank level violations, and then please show it to us. Okay, so here's the legend, and here are the numbers again. Okay, so with this, we can finalize the formulation of the problem. We can just come back here and save the file. I'm gonna save it here. Just gonna call it project 1, save it in a known location, and then that way we could just come back later and start from here. Okay, so this is the end of the formulation stage. In the next video I will show it to you, I will show to you the plan, the evaluation and the plan section. Okay, thank you.